Atmospheric Circulation System by Dr.Mohammed Azeez Saeed, Assistant Professor, College of Basic Education, Salahuddin University, Erbil. Latitudinal atmospheric circulation. Atmospheric circulation is the large-scale movement of air and the means by which heat is distributed on the surface of the Earth. The large-scale structure of the atmospheric circulation varies from year to year, but the basic structure remains fairly constant. However, individual weather systems, multitude depressions, or tropical convective cells occurs randomly, and it is accepted that weather cannot be predicted beyond a fairly short limit, perhaps a month in theory, or currently about 10 days in practice. Nevertheless, the average of these systems, the climate, is stable over a longer period of time. Atmospheric circulation system, the wind belts are divided into three cells: the Hadley cell, the Ferrel cell, the polar cell. The Hadley cell is the atmospheric circulation pattern that George Hadley described to provide an explanation for the trade winds. It is a closed circulation loop, which begins at the equator with warm, moist air lifted aloft in equatorial low-pressure areas to the tropopause and carried poleward at about 30 degrees north or 30 degrees south latitude. It descends in a high-pressure area. Some of these descending air travel equatorially along the surface, closing the loop of the Hadley cell and creating the trade winds. The Hadley cell is more accurate to be described it through the thermal equator, which undergoes a semi-annual north-south migration. The second cell of the atmospheric circulation system is called the Ferrel cell, theorized by William Ferrer. Is a secondary circulation feature, dependent for its existence upon the Hadley cell and the polar cell. It behaves much as an atmospheric ball bearing between the Hadley cell and the polar cell, and comes about as a result of the high and low pressure areas of the mid-latitudes. For this reason, it is sometimes known as the zone of mixing. At its southern extent, in the northern hemisphere, it overrides the Hadley cell, and at its northern extent, it overrides the polar cell. Just as the trade winds can be found below the Hadley cell, the westerlies are found beneath the Ferrel cell. Thus, strong high-pressure areas which divert the prevailing westerlies, such as a Siberian high, which could be considered as an extension of the Arctic high. While the Hadley and polar cells are truly closed loops, the Ferrel cell is not, and the telling point is in the westerlies, which are more formally known as the prevailing westerlies, while the trade winds and the polar easterlies have nothing over which to prevail. While upper-level winds are essentially westerly, surface winds can vary sharply and abruptly in direction. A low passing to the north or a high passing to the south from a northern hemisphere maintains or even accelerates westerly flow. The local passage of a cold front may change that in a matter of minutes and frequently does. A strong high passing to the north may bring easterly winds for days. The base of the Ferrel cell is characterized by the movement of air masses, and the location of these air masses is influenced in part by the location of the jet stream. which acts as a collector for the air carried aloft by surface lows. Surface lows follow the jet stream. The overall movement of the surface air is from the 30th latitude to the 60th. However, the upper flow of the ferrous cell is not well defined. This is in part because it is intermediary between the Hadley and polar cell, with neither a strong heat source nor a strong cold source to drive convection. The third cell is the polar cell. It is likewise a simple system. Though cool and dry relative to equatorial air, air masses at the 60th parallel are still sufficiently warm and moist to undergo convection and drive a thermal loop. Air circulates within the troposphere, limited vertically by the tropopause at about 8 kilometers. Warm air rises at lower latitudes and moves poleward through the upper troposphere at both the north and south poles. When the air reaches the polar areas, it has cooled considerably and descends as a cold, dry, high-pressure areas, moving away from the pole along the surface but twisting westward as a result of the Coriolis effect to produce the polar easterlies. The outflow from the cell creates harmonic waves in the atmosphere known as Rossby waves. These ultra-long waves play an important role in determining the path of the jet stream, which travels within the transitional zone between the tropopause and the ferrous cell. By acting as a heat sink, the polar cell also balances the Hadley cell in the Earth's energy equation. It can be argued that the polar cell is the primary weather maker for regions above the middle northern latitudes. While Canadians and Europeans may have to deal with occasional heavy summer storms, there is nothing like a winter visit from a Siberian high to give one a true appreciation of real cold. In fact, it is the polar high which is responsible for generating the coldest temperature recorded on Earth, minus 89.2 degrees Celsius at Vostok 2 station in 1983 in Antarctica. The Hadley cell and the polar cell are similar in that they are thermally direct. They exist as a direct consequence of surface temperature. The endless chain of passing high-pressure centers and low-pressure centers, which is part of everyday life for mid-latitude dwellers, is unknown above the 60 and below the 30th parallel. This is a schematic model of the latitudinal atmospheric circulation system cells. It can be seen that this circulation near the equator starts from the equator, circulates from the Earth's surface to the troposphere, tropopause, is a Hadley cell, and this is the position of subtropical jet streams, and this is the second cell of the atmospheric circulation system, and this is polar jet stream region here. So the ferrous cell between 30° north to 60° north, and this is the polar cell of the atmospheric circulation system, that's the North Pole, and also circulates between the Earth's surface to the tropopause. This schematic diagram is well illustrated. It can be said that this region above the equator, both south and northern equator, these are most of the year are cloudy regions, which is the region of sometimes it's called doldrums, or it's called intertropical convergence zone, ITCZ. Thank you for your listening and watching. Wish you all the best.